Hey guys, welcome back to another video. So today we're going to be looking at a really interesting concept or subject in mathematics called imaginary numbers. So turns out, guys, that we can do some really cool things. Not all numbers are real. So you've probably seen that in math a lot, like all real numbers as like a domain or as a range, like all real numbers, or you talked about real numbers. Today we're going to look at the other side of the coin and we're going to delve into the idea of numbers that are not real or what we call imaginary numbers. And it turns out that even though they're called imaginary numbers, it's a little bit of a misnomer because we can actually use imaginary numbers in real math. So we're gonna dive right in and take a look at it. So here's kind of our basic understanding of an imaginary number. Imagine you take the square root, and I'm using my mouse to draw this, so I'm sorry guys if it's not up to your standards when it comes to my handwriting. But let's say you take the square root of -1. If you type that into your calculator, if you try to do that, it's going to give you an error because we learned a long time ago we can't take the square root of negative numbers, or can we? So this right here, this square root of -1 is the definition of what we're going to call I. And I stands for an imaginary number. And this is kind of our basic understanding. So square root of -1 is equal to I. Um, Now you can read over these properties, property 1 and property 2, and kind of try to think through them, try to understand what they're saying here. But imagine we take I and we square it. So if we squared, yeah, so I squared, let's do that. This is supposed to be an I squared. Really what we're doing here is we're taking the square root of -1 and we're squaring it. So when we square square root, we'll get whatever's underneath the radical. So I squared is just -1. So even though I is imaginary, when we square it, when we square an imaginary number, we actually get a real number in return. So I squared is -1. So just remember that I squared is -1 and I equals square root of -1. All right, let's look at a few examples of where we might use this. Also, guys, when you're adding, I guess I'm going to mention this real quick. Anytime you're adding or subtracting what we call complex numbers are simply numbers that are a combination of real numbers and imaginary numbers, like 5 minus 2i. So 2i is an imaginary number because it has an I in it, but 5 is a real number. So altogether, we call this whole thing a complex number because it's a combination of real numbers and imaginary numbers. But anytime we try to add up, or anytime we try to add up two complex numbers, you're just going to add the real numbers together. So like the A and the C, and then you'll add the imaginary numbers together. So um, it's kind of like terms where you have 5 plus 2x. Um, you can't add the 5 and the 2x together. It's the same way with these. So you can kind of think of it as adding polynomials or anything like that, where you're trying to keep your like terms the same. So same thing down here when you're subtracting complex numbers. We can subtract the a and the c because those are real numbers, and then we can subtract the imaginary numbers. Uh, so that's how we would do that. All right, let's look at a few examples. So square root of -49. Way we can do this is we can take anytime you take the square root of a negative number, you can just take the square root of the number. So square root of 49 is what? 7, right? So square root of 49 is 7. And isn't it plus or minus 7? Actually, I don't think we'll do it with the imaginary numbers. But anytime you take the square root of a negative number, you're just going to take the square root of the of the number and then put an I beside it. Okay, so square root of negative 49 is just 7i. Square root of negative 49 is just 7i. And remember, the I is just the square root of negative 1. So really what we did was we split square root of negative 49 into square root of 49 times square root of negative 1. But you can just remember it this way. Square root of a negative number is just square root of the number with an I on it. So 2 here would be 2i. 2i. What about this one down here? So we'll have negative 2 out front. So it's negative 2 times, and then what's the square root of negative 100? Well, remember, this is supposed to be a times, not a minus. It's going to be 10i, right? 10i. So we can multiply these together. Negative 2 times 10i is negative 20i. Negative 20i. All right. So there you go. And you can just kind of fill the rest of these in. 3, 5, and 6 I'll let you kind of practice on. Let's look at this. So let's say you have an equation and you're trying to find values of x and y that satisfy the equation. So what we want is we want our i's to cancel so that we get just a real solution out of here. So how can I get my i's to cancel in this equation? Well, we have a plus 1i here. It'd be good if we had a plus 1i over here, because then we could just subtract it from both sides and it would disappear. So my strategy is, what can I multiply by negative I to make it a positive I? And the answer is negative 1. So if we put in a negative 1, if y equals negative 1, negative 1 times negative I is just positive I. And then we'd have positive I on both sides and we could subtract them. So then if we did that, if y was negative 1, we'd have negative 10x equals 30. Negative 10x equals 30, because the i's would cancel. And then we can just solve it. Divide by the negative 10, and x will equal negative 3. So x equals negative 3, and y equals 1. So think about it over here on this one, on number 8. What could I multiply right here by this y so that I would get a negative 7i? Because if we have a negative 7i on both sides, then they'll cancel, or we can add we can add 7i to both sides, and they'll like cancel out of the equation. So what could I multiply? What y could this be to turn this into a negative 7i? All right, so 1/2 times what gives you 7. So try that out, and then you can solve it. Let's move on and look at just 1 or 2 more examples. So again, treat these problems like they're like terms. So we can add the negative 8 and the negative 1 together to get negative 9. So add these two together. And then we can add the 3i and the negative 2i. So we would just get positive 1i, or just plus I. And that right there, the answer right there, negative 9 plus I, that's a complex number because it's a combination of a real number and an imaginary number. All right, let's look at number 10. With number 10, we're subtracting two complex numbers, so we can subtract the real numbers. 36 minus 12 is 24. And then we can subtract the i's. So negative 3 minus 24 would be negative 27i. So again, just treat these kind of like they're variables, even though they're not. The I is not a variable. So make sure you understand that. But you can kind of treat them like they are. And again, this is another complex number because it has a combination of real numbers and imaginary numbers. All right, do numbers 11 and 12 on your own. And let's do one more example down here. Let's do number 13 together. So this is multiplication, right? So we could kind of FOIL this. Negative 1 times 15 is negative 15. Negative 1 times negative I, isn't that positive I? 9i times 15 is, well, let's see, 10 times 15 would be 150. So minus a 15 would be 135. So that's 135i. Might have to check me there, guys. All right. And then we have 9i times negative I. So we have negative 9i squared, right? Negative 9i squared. So we have two i's there, negative 9i squared. But remember, I squared is just negative 1. Remember that from up above. I squared is just negative 1. So we can simplify all this. Let's do negative 15. And then I plus 135i is just 136i. Okay. And then I squared is negative 1. So we could replace that I squared with a negative 1. Negative 1 times negative 9 is just positive 9. And then we could add these two together, 9 and the negative 15. So we would get, for our final answer, we would get negative, let's see, 6 plus 136i. 136i. So again, kind of just FOIL this. You know, we did the 1 times that, and then times that. And then we did 9i times this, times this. All right, to get that first step. Then we can combine the i's. I squared is negative 1. Negative 1 times negative 9 is positive 9. Then we could add the 9 and the negative 15 together to get negative 6. So try number 14 on your own, see what you get for that. The last kind of problem we want to look at is down here where we can solve equations now with um, square roots of negative numbers. So if we were to solve this equation, we could subtract the 25 over here, right? So we'd have negative 25 equals 5x squared. So next thing we would do is divide by 5. So we'd have negative 5 over here equals x squared. And then you want to take the square root of both sides. So we'll have x equals the square root of negative 5. Which before we would say we can't do that, but now we know we can. So we could write that square root of 5 doesn't come out nicely, but I wonder if they meant to do that. Because square root of 25 would have been nice, but oh well. So square root of 5, we could write it like as a decimal with an I. So let's see what square root of square root of 5 is. So 5 square root gives us about 2.24. So we could write it as about 2.24 I. Remember, anytime you take square root of a negative, just take square root of the number and add an I in there. And there you go. There you go. So 2.24 I. And really, guys, to right here at the end of the video, this is the last thing I want to say. Really, to be accurate, you need a little plus or minus out front. Because remember, with square roots, you really should have a plus or minus because it could be positive. It could be a positive answer, but it could also be a negative answer. Anytime you take the square root of a number, you should do a plus or minus out front because the negative would give you the exact same thing. So that would also be a solution. Anyway, guys, try number 17 and 18 on your own. Let me know if you have any questions. Always feel free to leave comments down below, and I'll get back with you. Um, but anyway, thanks guys for watching. Hope you enjoyed the video, and I'll see you in the next video. Take it easy, guys.